folks, I just wanted to make a little video to describe just how to debug with m65dbg, and maybe just a quick walkthrough of the docs first, the various compilers that it's supporting right now: Ovus, Acme, CC65, CA65, and BitShifters, BSA compiler as well, which is used for the Mega65 ROM. And I've had other videos where I talk through the various facilities, but I'll just run through. That's your PC with the m65dbg running on it. You could hook up the USB port to the Mega65's serial port, and that then talks to the serial monitor on the Mega65. That's the connection on the Nexus board. You could also use the ZEMU emulator as well and talk over Unix socket or TCP, and yeah, it's a similar sort of conversation. Then it sort of talks about how to make that connection with ZEMU. That's the old UART socket way. That's specifying it with a TCP port. Then on the Mega65dbg side, you can either do it the Unix way, pointing to the same socket, or you could just specify the term TCP for a device name for a TCP connection. If you want to get really fancy, you can also specify a host name and a port number if you want to work remotely. But if you do want to debug with ZEMU, right now the only best way is to use this forked branch I've got, where I've sort of had to make some repairs to the UART monitor on the ZEMU side to talk a bit better, a bit less buggy. So yeah, you'd have to clone that branch. That's my one, and from this branch, and build that, and you should be good to go. Installing the Mega65dbg right now, it's a source only, so you'd have to clone this out. I've got some steps underneath here, so just clone it. You might need a few prerequisites, and then just type make. It's as easy as that. A little bit of help available. Serial port names, yeah, there's info on how to find your serial port name. But maybe that distinction of the raw serial monitor commands versus the more enhanced commands that the m65dbg offers. The raw ones are the ones that the UART monitor on the Mega65 offers. These sorts of commands tend to be just single letter commands with no space in between them and the parameters that follow. They tend to be bare bones commands that the hardware supports, and they make you crave a little bit more. But it's tools like m65dbg make use of these raw commands and then sort of build enhanced versions of them and extra facilities and such. And yeah, there's a few other videos available with other sort of walkthroughs on this. That's an example of a simple session of the sort of things. Yeah, perhaps we can try this. I've got just a camera view of this is my real hardware, and we can get up a terminal. So yeah, this is m65dbg. I say device is this, my serial USB, and I'm in. And then yeah, we could maybe T1 will pause the CPU. We could disassemble the current point. Next. Oh, I type N for next, but to repeat the last command, I can press enter. I can do a backtrace. If I want to go down the backtrace, I can, or up the backtrace, I can. What other things can I demonstrate? Well, this is just the raw sort of experience on its own. Maybe sort of seeing the distinction of behavior. Okay, R for register, yeah. B to set a breakpoint. We could make a dummy example of, let's say, actually prior to that, maybe we could make a little assembly. Yeah, there's an inbuilt assembler inside here too. Let's say, I don't know, what we do? 5, stack it somewhere, I don't know, 800. Okay, so that's in there. I'll just unpause the CPU, and I could type on my real hardware. Another feature you could use is you could type from the monitor too. Say bank 0 sys 8197. Press enter. Yep, and it put that letter in the top there. Okay, so it's assigned a little bit of assembly work, but maybe we want to put a breakpoint at the 2005, so we could go B2005 there, and this time I'll use the real hardware. I press there, and now you can see it's paused, so I can type this, and we can see we're there. Oh, okay, it's gone at the next command, the stacking of it, so I can go next. Oh, and an interrupt happened. Well, that's another thought. Yeah, interrupts happen from time to time, and they interfere with your debugging. So perhaps I'll just let this one go, and I'll show you another trick. So we can go in here and go bank 0 sys. I'll press enter on the m65. It's breakpoint is hit again. Here, where are we? Oh, here we are. Okay, 2007. This time I don't want interrupts to interfere with me. So what you can do in the tool here is you can type in assembly instructions as one-shot instructions. So here I'm going to set the interrupt flag to disable interrupts. So I do that, and now our debugging session won't be interrupted by any further interrupts. And maybe you can confirm that. Where are the registers here? I think one of them is the interrupt flag. Let's clear the interrupt and print the registers again. You can see the I has gone here. So let's set interrupts again and show the registers. We see the I is back. So yeah, that's just a nice handy trick. And I did this also because it's a nice handy way to sort of have like an immediate mode to learn about instructions. Perhaps you want to load A with a particular value, and look at the area, it's changed from 5 to 4. Maybe you'd want to learn about, I don't know, ASL. Is that how it worked? I forget. Okay, now it's gone from 4 to 8 and so forth. So yeah, it's a way to sort of experiment with assembly instructions, and could be a good educational way of doing things. I found it very useful for like branch instructions and comparison instructions, like branch or carry clear and things, because I find them quite confusing, and I tend to study how they affect the registers and all the processor flags. So yeah, that's pretty useful. Okay, oh, it got upset with me. It's jumped into the monitor there. Maybe I'll just exit that for now. Oh, it's paused again. Okay, maybe I'll just pause it for now, get my bearings. Okay, another thing to just be aware, inside the tool you can press type question mark, and these will give you those raw instructions, the simple form instructions. And if you type the full word help, you get the full list of m65 debug instructions, which are a bit meatier. Let's say you can have a list of watches here. Maybe you'd like to watch points in memory. Let's say watch a byte, D020, what's the border color doing, or watch another. Maybe you like to watch a word instead. I don't know, colors. This is another thing. Well, actually, maybe before that, now we can see a list of watches there. Or we can maybe watch the full word at D020, and maybe I want to give it a manual symbol name. I'll call it colors. So next time I type watches, it's showing 6 and 6. And oh, that's another thing. You've got the tab completion here. Pressing tab on a few letters can complete things for you. All right, I'll think of other things to show. Yeah, okay, the docs, we can walk a little bit through this. Let's say we provide a dump command, which is a bit more meatier than the raw command available. There's a sort of shortcomings of the raw command here. In the raw command, you'd have to type something like M, and you'd only get this sort of hex output, whereas with the more mature dump command here, you can get your hex and also the ASCII form on the right of it. So yeah, we could give that a try. So I'll bring the camera up again. So yeah, doing whatever 777. Oh, this is to view the contents of the screen. Okay, and then let's dump. Use the dump command instead. Oh, and I guess they mentioned the Petsky flag. Turning that on. Let's try again. Okay, we see more of the contents of the screen data there. And that's not to say that the raw commands are useless. No, they are still quite useful. It's just a matter of getting acquainted with them and seeing which one suits you for which purpose. Let's say this set command set at 800, and you can set several bytes at 800. I'll set a few here, and you can see it set them up here for you. So there's convenience. It's just a matter of getting acquainted with them. Okay, maybe it's worth making a distinction between the dump command and the mdump command. So the dump command works in the 64-bit space. So it will just let you see whatever's mapped in whatever location. So maybe if you do C00, actually I don't know what things are where. You're seeing sort of, okay, E00, you're seeing sort of kernel space and things like that. But perhaps if you want to see just the RAM that's located there instead, you could use mdump, and this is now in the 20-bit address space. And you'll see the contents there are quite different because that's the raw RAM. Yeah, you're not touching the ROM. Because bank 0 of 64K is the RAM, and bank 1 is a RAM 2, and banks 2 and 3 are our ROM, just for give you some bearings. Yeah, disassembly gets described here. Again, that's in 16-bit space DIS. So they gave an example of here. If you just use 1 on its own, it's that 1. Maybe if you add another number after, you can get that line plus 10 lines after it. And mdis, by distinction, again, that's in 28-bit address space. So if we were to try the same thing with mdis, we're looking in memory at this point. There probably won't be much in memory there. But if we were to look at maybe ROM space into the third bank of 64 kilobytes, yeah, we can see the ROM data in there again. Okay, and perhaps I just want to describe symbolic debugging via the tool. So like I mentioned, there are various different compilers it can work with, and the various output files that they produce can be read in, and yeah, I provide some documentation here for OFIS, Acme, just to be sure that you sort of compile them with various arguments to ensure you get list files and map files and their equivalents. Acme, BSA, I think BSA didn't need it, it produces list files automatically, CC65 and CA65. And KickAss and KickC, potentially in the future, I know they've got similar sort of files that they output too, so yeah, it's not out of the question that they can be supported later on. Okay, so let's give some of these a bit of a test drive. So let's say if we were working on the Mega65 ROMs, which are here, and I'll just list this directory here. And you can see for each source file, it's produced a list file and such, so we can make use of those. And when we run Mega65dbg this time, in the output we'll see it loads these files up. And so we have symbols available now. Let's say the play command, which was one I debugged fairly recently. We can have a look at the symbol play, and we can see it's located at this address. So if we were to type, this 48C6, we get the well, you see we're now seeing the the listing file pointing to what's at 48C6, which is this interrupt flag. And so we could, let's say, set a break at play. We don't have to type 48C6, we can use the symbol name. So if I type, I'll just put that there, break play. And so now if on the hardware I type play, Mary had a little there, and I press enter, we see it doesn't progress to the ready because it has been paused. And yeah, the hardware breakpoints they don't give you a hit on the actual address you request. They usually get a little later or sometimes even earlier, which is quite annoying. But either way, we're here. You can see, let's say, we're stacking something in a variable called voice. We can use watches to watch that value. Maybe we can watch voice. So then if we want to look at our list of watches of any sort of key variables we're monitoring, we can do that easily. And we can tie that in, like we can step through now and you can see watches are automatically put at the top for me here. I think that's because I set an auto watch command to be 1 if you do that. And on each next, the screen is clearing for me, so I can type next. That's done from the auto CLS command, which you can turn on or off. Just find it convenient, like a cheap way to get this sort of preview mode. And so yeah, we can step through and monitor things this way and add as many watches as we like. So yeah, and maybe you're not happy with, say, with the amount of size of that preview, so you can use the scope command to make it bigger. Maybe make it 15 or 20, whatever suits you. I'll just make it 15 for now. Or maybe while you're debugging and stepping through things, maybe you wish you could see a little bit further ahead or a little bit further behind. So if you want to see a bit ahead, type offs for offset. Maybe go 10 ahead. If you want to see a bit further, 20. If you want to see a bit further, 30. Go back to where you were, 0. Or if you want to see a little bit behind where you were, just do offs minus 10. Or offs, that's because there we go, that's better. Offs minus 20, offs minus 30, and so forth. I'll bring it back to where it was. Okay, so that was the BSA compile output, debugging with BSA. I'll turn that back on. So maybe if we were trying to think of other things I've been debugging recently, it's been more in the core, I think, and inside Hippo. So Hippo is compiled with the Acme compiler. So inside here you'll see it produces files like hiccup.rep and hiccup.sim, and those can be picked up via the tool as well. So if we start up now, it'll load those files. So I'll just have to think of something that brings us into the hypervisor. I'll give it some thought for a second. Yeah, now I remember that I was doing a lot of debugging in the DOS reading of the directory. So if I break in there, maybe if I maybe try and jump into the freezer, that might call it. Okay, so I jump into the freezer and it's installed now. So if I go disassemble here, just change the scope to something a bit smaller. And I believe, I'm in DOS ASM, so maybe it's gone somewhere close. If I bring offset maybe minus 10, look a bit back, DOS find first. Yeah, this is familiar territory. It might be one down the backtrace. So if I go down the backtrace, it's in DOS find first, which was DOS read file into memory. And I'll go down a bit more. Attempt to load char ROM. But anyway, down and up work fine, and I feel like it's somewhere in the area of reading the directory, but yeah, I won't dwell on it. I think probably it's further up, maybe. If we go up, I think whatever jumped the DOS find file was probably DOS read dir. But anyway, yeah, that's working okay too. Offs0 brings it back. Another thing is probably when I jump into this, maybe you notice it does a few things for me already from the get-go. I'll just make it screen. Let's say when I jumped into m65dbg here, am I still recording this? I'll just check. Yep, I am. So it already threw up some watches for me that I was keeping an eye on from last time. It already set this scope size for me, and how did it get all these things automatically? It's because in this folder, I made a m65dbg init file. So if I open that one, inside that one, I pretty much put in all the commands that I was interested in just automatically typing every time it opened up, only when it's run in this folder. So when I'm in this Hippo debugging mindset, yeah, I just put any sort of relevant Hippo sort of variables I'm monitoring. I'm dumping here the log file name, information, and I change the scope to 20. And beyond that, there's also a global file that's in your user folder. wherever that is on your system. For me, I believe it's in here. So within this one, I've just put auto CLS to turn it on and auto watch to turn it on. So yeah, you can tailor your startup to be whatever you prefer. So that's what I preferred for when I'm debugging Hippo. But perhaps when I'm debugging the freezer, I want something different. So that was in m65 freeze menu. So for the freezer, this was compiled with CC65 for the most part. And what kind of files was there here? I believe there were list files and label files and map files. Yeah, they're all here. And so if we were to run m65 debug here, it'd pick all of those up. So if we were doing something interesting in the freezer, we could maybe break on a label of interest there. Let me just pause and think what's an interesting label. Another advantage with the tab sort of form of autocomplete was the suggestion. So maybe it was draw something, so I press tab again a few times and the other possibilities pop up for me to remember. Maybe I want to break on draw freeze menu. Okay, so I'll just unpause the CPU. Hopefully we're at a point where it's just about to start drawing the menu for the freeze menu. So if I disassemble here, it's gone off to some funny place. Let me just skip this part. I think this is just okay. Now we're inside an L copy that I think was used within the drawing of the menu. So if there's a backtrace here, if I go down, I see it's some pre-draw freeze menus being triggered, and that's just prior to the draw freeze menu I requested. And that's just the quirk of this hardware breakpoints, that they tend to break on things either before or after, but usually never where you want them to break. Maybe that brings up a more interesting possibility. I've been working on software breakpoints, which have a bit more better sort of response where you type sbreak and the location of interest, and that's performing a bit better in giving you exactly where you want. So sbreak draw freeze menu. Okay, it's set there. Now if I type C for continue. Okay, now we're inside draw freeze menu exactly, and we can sort of break through. And for CC65 debugging, I don't have the smarts to sort of let you debug at the C level, you know, the lines of C code. I'd like to one day once I figure out how to. But right now you're debugging each sort of assembled sort of version, and you're stepping, so if slot number, so then you'd have to sort of step through these and look at the branching instruction to see whether this happened. But you can also, let's say, look at the stack and where this slot number is, and sort of maybe print it out. From memory, I can't remember where this slot number is located, but yeah, if you did know, you could sort of watch a byte and some number and say, here's this local slot number. Or actually, was it a if it's a is it a slot? Oh, it's a global variable. Yeah, if it's a global variable, then that's no problem. We can watch that easily. I just say watch byte slot number. Might have to decrease the size, and if I just do offset 0, which is my shorthand, so yeah, we can keep an eye on, let's say, what the slot number is. Or if we don't want to use the watches, we can just print byte slot number, and we get the same thing in that sort of form. Okay, yeah, that's covered. Okay, so maybe just to demonstrate the connection to Zemu. So if I just check the branch I'm on, I believe I'm still on this 220 UART one update branch with the fixes, the Zemu. And so running that, xmega. So here I specify the UART mon argument with the TCP port of 4510, pressing enter on that. Here we go, we're in there. And you don't have to use that UART mon argument. You could do, like, just select this manually, up to you, and you could toggle that on and off. Whoops, I've turned it off. Anyway, I'll turn it back on. Oh no, it's okay. So anyway, this is running. So if we want to just quit this now, and now I'll just make that bigger again. So instead of the serial port connection here, I'll just specify TCP, and here we are, we're connected to CMU. And I could do similar sorts of things, like maybe set part of the screen to different bytes, say 456, and you can see the same thing is happening here. It's all working in the same fashion. So, and yeah, we can pause the CPU, we can disassemble. I don't know if we're, I should probably go one word, next, yeah. So yeah, we can use this thing the same way and debug with source, simple symbolic debugging as well. So yeah, maybe I think I've covered all that I wanted to, but maybe this last thought of, well, why not share pre-built executables? I guess one factor is it's limited time to work on this. When I can, I just do what I can. So source is quick and easy for me, and I think so. Yeah, there's just a limited time is a factor. I think also another factor is, I guess I want to encourage others to use the source so that if they encounter problems, they're in a good position to fix it. So that's what I find. Like if it could be frustrating that you're trying to do some debugging activity on something you're working on, and a debugger doesn't work the way you want to. And sure, you could ask the developer for help and assistance. They might be busy, but you know, if you really need something fixed or working the way you want, it's great to just have the source at hand, dive into it, and sort of tweak it as permits. And yeah, I think that's an asset to all of us. You know, anything you fix and improve there could help anybody else too. And, you know, I'm not perfect. I'm going to make mistakes. You know, I've had to fix bugs along the way on every occasion I've used the tool, and I imagine it's going to be no different for any other tool. So yeah, at least with this M65 debug tool, it's been around for a while now, a few years. So I've made my fair share of mistakes and learned from them and fixed and repaired things, and you get the benefits of that, and you're in a position to add on top of it as well. Maybe then, like if to put your mind at ease, like there isn't too much source code to it. Like if I look at the C files, I imagine the main file of interest is commands.c. So you know, if you were to sort of dig into that and take a look at it, maybe go to the top, and probably the points of easy honing yourself is to see how each command is handled. So if you had an issue with, let's say, the watch system, it's not watching the way you want it, you want to print the output differently, well, yeah, you can then maybe search for this command, watch dump, and hopefully these names are kind of akin to what they were when you typed in the program itself, or maybe printing a string or seeing the backtrace. Maybe you want to do something. So then you can maybe just search for this function, command backtrace, and just start digging around here, make your tweaks, print something differently, and then exit and, you know, just make and rebuild it, and it's done. And then, you know, any changes and improvements you make, you're welcome to make a PR and send it my way. And you know, if it's nice, we can put it in for everybody too. So yeah, anyway, that's why I kind of think that's a good way to go for open source, sort of, so everybody wins in that sense. But anyway, hope this walkthrough helped, and all the best.